This is SpaceTime, Series 26, Episode 146, for broadcast on the 6th of December 2023. Coming up on SpaceTime, a new perspective on Mars, determining the composition of the rock comet Phaethon, and unveiling salt glaciers on the planet Mercury. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers have manoeuvred NASA's Mars Odyssey spacecraft to provide a new panoramic horizontal view of the red planet. The reorientation was carried out to help celebrate Odyssey's 22nd year in orbit around Mars. The spacecraft captured a series of stunning images showcasing the curving Martian landscape below gauzy layers of clouds and dust. When stitched together end-to-end, the 10 images offered not only a fresh and stunning view of Mars, but also one that will help scientists gain new insights into the Martian atmosphere. The spacecraft took the images back in May from an altitude of around 400 kilometres. That's about the same altitude the International Space Station flies above the Earth. Jonathan Hill from Arizona State University, who was the operations lead for Odyssey's thermal emission imaging system camera, says no Mars spacecraft had ever before taken this kind of view. If there were astronauts in orbit above Mars, this is the perspective they would see. The reason why the view is so uncommon is because of the challenges involved in creating it. Engineers at NASA's Jet Propulsion Laboratory in Pasadena, California, which manages the mission, together with scientists from Lockheed Martin Space, which built the Odyssey spacecraft, and the mission managers, spent 3 months planning the observations. See, the infrared camera normally looks straight down, and its sensitivity to warmth allows it to map ice, rock, sand and dust, along with temperature changes on the planet's surface. It can also measure how much water, ice or dust is in the atmosphere, but only in a narrow column directly below the spacecraft. That's because the camera is fixed in place on the orbiter, usually pointing straight down. But to get this new perspective meant a more expansive view of the atmosphere. Seeing where those layers of water, ice, clouds and dust are in relation to each other, whether there's just one layer or several stacked on top of each other, will all help scientists improve their models of the Martian atmosphere. Think of it as viewing a cross-section, a slice through the atmosphere. It lets you see a lot of details you can't see from above. But because the camera can't pivot, adjusting the angle of the camera requires adjusting the position of the whole spacecraft. In this case, mission managers needed to rotate the orbiter around 90 degrees, while at the same time making sure the sun would still shine on the spacecraft's solar panels, but not shine on sensitive equipment which could overheat. The easiest orientation to achieve all this turned out to be one where the orbiter's antenna is pointed away from the Earth. That meant the team would be out of communications with Odyssey for several hours till the operation was complete. Luckily, the whole thing was a big success, and the Odyssey mission hopes to take similar images in the future, capturing the Martian atmosphere across multiple seasons. To make the most of their efforts, the mission also captured imagery of the Martian moon Phobos, the 7th time the orbiters imaged the moon, in order to measure temperature variations across its surface. But the new viewpoint meant they received a different viewing angle and lighting conditions of Phobos compared to previous images. And all that makes this a unique part of the Phobos dataset. The new imagery provides insights into the composition and physical properties of the moon. Further studies could help settle debate over whether Phobos, which measures about 25 kilometres across, is simply a captured asteroid from the nearby main asteroid belt, or an ancient chunk of the Martian surface that was blasted off into space by an asteroid impact. It's worth noting that NASA is participating with JAXA, the Japanese Aerospace Exploration Agency, in a sample return mission to Phobos and its sister moon Deimos, known as the Mars Moon Explorer, or MMX. Consequently, Odyssey's Phobos imagery will be helpful to scientists working on both Odyssey as well as MMX. This report from NASA TV.
Imagine you're an astronaut in the International Space Station.
Roger, you're loud and clear here also.
But instead of being in orbit around Earth, you're in orbit around Mars. I work for NASA's Mars Odyssey orbiter, and we just took a bunch of new images that show exactly how the planet Mars would look from that exact same perspective. If you were an astronaut, the first thing that would catch your eye are beautiful craters, which of course look much different than what you would see on Earth. But the second thing you would see, because you're looking at the planet from an angle, is the structure in the clouds. And because Mars Odyssey has a heat vision camera, it can actually tell the difference between different kinds of clouds. On Mars, we have CO2 ice clouds, we have water ice clouds, and we have dust clouds. In order to get these images, we had to do something with the spacecraft that we've never done before. Usually, our camera faces straight down for mapping. In the past, we've experimented with rolling the spacecraft out so that we can catch pictures of some of Mars's moons, like Phobos, a potato-shaped, beautiful moon that you might have heard of. But this time, we had to do something a little more extreme. We had to rotate the spacecraft all the way to the horizon, then we had to keep it that way for an entire orbit. Odyssey has been going strong for 22 years.
We have ignition and liftoff, carrying NASA on an Odyssey back to Mars.
That makes it the longest-lasting spacecraft that has ever been sent to visit Mars. So what's next for Odyssey? Well, next year we're going to hit 100,000 orbits around Mars. We also have several ongoing science campaigns. One is a rock mapping campaign that will help us land future missions more safely on the surface. You're also taking advantage of our special dawn-dusk orbit to map clouds, fog, and frost that only exist at certain times of day. And we are also planning our next maneuver to look out at the clouds on the horizon again.
And in that report from NASA TV, we heard from Mars Odyssey Deputy Project Scientist Laura Kerber from JPL. This is SpaceTime. Still to come, determining the composition of the rock comet Phaethon and unveiling salty glaciers on the planet Mercury. All that and more still to come on SpaceTime. The so-called rock comet Phaethon has always been a puzzle for astronomers. The 5-kilometre wide space rock, which generates this month's annual Geminid's meteor shower, has puzzled astronomers for decades, with its asteroid-like appearance and comet-like orbit and tail. Now, new infrared spectra of rare meteorites has helped scientists determine the composition of the asteroid, or is that comet. Phaethon displays its comet-like tail for a few days when its orbit brings it close to the Sun. However, the tails of comets are usually formed by vaporizing ice and carbon dioxide. Phaeton's tail, however, is based on rocks. And also, cometary-like tails usually start to appear as comets pass inside the orbital distance of Jupiter from the Sun. When the surface layer of a comet breaks up, the detached gravel and dust continues to travel in the same direction as the comet, causing small fragments, often called shooting stars, as they encounter the Earth's atmosphere and break up. Until now, theories about what happens on Phaeton's surface near the Sun have remained purely hypothetical. What's actually coming off this asteroid or comet, and how? To answer this riddle, scientists had to first understand the composition of Phaethon. So now, scientists from the University of Helsinki have reanalyzed the infrared spectra of Phaethon, measured by NASA's Spitzer Space Telescope, and they've compared that to infrared spectra of a number of meteorites measured in laboratories. The authors found that Phaeton's spectrum corresponds exactly to a certain type of meteorite known as a CY carbonaceous chondrite. This is a very rare type of meteorite. In fact, only 6 specimens are known. Asteroids Ryugu and Bennu, the targets of recent JAXA and NASA sample return missions, belong to CI and CM meteorites. All 3 types of meteorite, CI, CM and CY, originate from the birth of the solar system and partially resemble each other. But only the CY group shows signs of drying and thermal decomposition due to recent heating. All 3 types also show signs of change that occurred during the early evolution of the solar system, where water combines with other molecules to form phyllosilicate and other carbonaceous minerals. However, CY-type meteorites differ from the others due to their high iron sulfide content, which suggests a very different origin. Analysis of Phaeton's infrared spectrum showed that the asteroid, or is that comet, was composed of at least olivine, carbonates, iron sulfides, and oxide minerals. All of these minerals support the connection with CY meteorites, especially iron sulfide. The carbonates suggest changes in water content that fit the primitive composition, while the olivine is a product of thermal decomposition of phyllosilicates at extreme temperatures. Using thermal modelling, the findings reported in the journal Nature Astronomy were also able to show what temperatures prevailed on the surface of the asteroid and when certain minerals broke down and released gases. When Phaethon passes close to the Sun, its surface temperature rises to about 800 degrees Celsius. The CY meteorite group fits this well. At similar temperatures, carbonates produce carbon dioxide, phyllosilicates release water vapour, and sulfides sulfur gas. So, all the minerals identified on Phaethon appear to be composed of the same minerals found in CY-type meteorites. The only exceptions were the oxides portlandite and brucite, which were not detected in the meteorites. However, these minerals can form when carbonates are heated and destroyed in the presence of water vapour. The composition and temperature explains the formation of a gaseous tail near the Sun. The authors then used experimental data from other studies in conjunction with their own thermal models to show that when the asteroid passes closest to the Sun, gas is released from the mineral structure of the asteroid. This can cause the rocks to break down. In addition, the pressure produced by the carbon dioxide and water vapour is high enough to lift small dust particles from the surface of the asteroid. Sodium emissions can explain the weak tail observed near the Sun, and thermal decomposition can explain how dust and gravel are released from Phaethon. But should we be thinking of it as an asteroid or a comet, or are they really the same thing, depending on how icy they are? This is SpaceTime. Still to come, unveiling salt glaciers on the planet Mercury, and later in the science report, a new study shows that heat-trapping greenhouse gases have reached a new planetary record. All that and more still to come on SpaceTime. Scientists have uncovered evidence of potential salt glaciers on the planet Mercury. The discovery, reported in the Planetary Science Journal, opens a new frontier in astrobiology by revealing a volatile environment that might echo habitability conditions found on Earth in extreme locations. The new findings complement other recent research showing that Pluto has nitrogen glaciers, implying that the glaciation phenomenon extends from the hottest to the coldest environments in our solar system. The study's lead author, Alexis Rodriguez from the Planetary Science Institute, says these locations are of pivotal importance because they identify volatile-rich exposures throughout the vastness of multiple planetary landscapes. These Mercurian glaciers, and yes, that's how you say it, distinct from Earth's, originate from deeply buried volatile-rich layers exposed by ancient asteroid impacts. Models suggest that salt flow likely produced these glaciers and that after their emplacement, they retained volatiles for well over 1 billion years. Specific salt compounds on Earth create habitable niches even in some of the harshest environments where they occur, such as the arid Atacama Desert in Chile. This line of thinking leads at least to the possibility of subsurface areas on Mercury that might be more hospitable than its harsh surface. Rodriguez says these areas could potentially act as depth-dependent Goldilocks zones, analogous to the region around a star where the existence of liquid water on a planet's surface might enable the existence of life as we know it. But in this case, the focus instead is on the right depth below the planet's surface, rather than the right distance from a host star. The groundbreaking discovery of Mercurian glaciers extends science's understanding of the types of environments that could sustain life, adding a vital new dimension to astrobiology and the potential habitability of Mercury-like exoplanets. The discovery challenges long-held views of Mercury as primarily devoid of volatiles. The glaciers on Mercury are marked by a complex configuration of hollows that form young, widespread sublimation pits. These hollows exhibit depths that account for a significant portion of the overall glacier thickness, indicating a volatile-rich composition. The hollows are conspicuously absent from surrounding crater floors and walls. A central mystery surrounding Mercury revolves around the genesis of its glaciers and chaotic terrains. Scientists used a new model which integrates the new observational data to examine the borealis chaos located in Mercury's northern polar region. It's an area characterized by intricate patterns of disintegration, significant enough to have obliterated entire populations of craters, some dating back 4 billion years. Beneath this collapsed layer lies an even more ancient cratered paleosurface, previously identified through gravity studies. Rodriguez says the juxtaposition of the fragmented upper crust, now forming chaotic terrain, over the gravity-revealed ancient surface suggests that the volatile-rich layers were in place atop an already solidified landscape. The new findings challenge prevailing theories on volatile-rich layer formation that traditionally centered on mantle differentiation processes, where minerals separate into different layers within a planet's interior based on density. Instead, the evidence suggests a grand-scale structure, possibly stemming from the collapse of a fleeting hot primordial atmosphere early in Mercury's history. This atmospheric collapse, if it happened, might have occurred during the extended nighttime periods of the planet when its surface wasn't exposed to the sun's direct intense heat. Underwater deposition could have significantly contributed to the emplacement of a salt-dominated Mercurian volatile-rich layer, making a significant departure from previous theories about the planet's early geological history. In this scenario, water released through volcanic degassing may have temporarily created pools or shallow seas of liquid or supercritical water, like a dense, highly salty stream, allowing salt deposits to settle. Subsequent rapid loss of water into space and trapping of water in hydrated minerals in the crust would have left behind a salt and clay mineral-dominated layer, which then progressively built up into thick deposits. This is space-time. And time now for another brief look at some of the other stories making news in science this week with the Science Report. A new report by the World Meteorological Organization has found that the abundance of heat-trapping greenhouse gases in the Earth's atmosphere has now reached a new record high, and there's no end in sight to the rising trend. The data shows that global average concentrations of carbon dioxide, the most important greenhouse gas, were a full 50% above pre-industrial levels for the first time. On the other hand, the rate of growth of CO2 concentrations was slightly lower than the previous year and the average for the past decade. But this was most likely due to natural short-term variations in the carbon cycle, and that new emissions as a result of industrial activities continue to increase. In fact, the last time the Earth experienced a comparable concentration of CO2 was 3 to 5 million years ago, when the temperature was 2 to 3 degrees Celsius warmer and sea levels were 10 to 20 metres higher than now. And it's not just carbon dioxide. Methane concentrations also grew, and levels of nitrous oxide, the third main greenhouse gas, saw its highest year-on-year increase on record from 2021 to 2022. The World Meteorological Organization says China remains the world's biggest carbon dioxide polluter, producing almost a full third of the global output, amounting to more than 10.1 million tonnes annually. That's almost double that of the United States, which is the second worst polluter, and 4 times that of India, which holds third place. They're followed by Russia, Japan, Iran, Germany, Saudi Arabia, Indonesia, and South Korea in 10th place. Next comes Canada, Brazil, Turkey, South Africa and Mexico, with Australia in 16th place, followed by the United Kingdom, Italy, Poland and Vietnam, rounding off the top 20. A small study which sequenced the entire DNA of 77 children with attention deficit hyperactivity disorder or ADHD and their families in the United States found variations in a single gene may account for a significant proportion of the genetics underlying condition. ADHD is usually thought of as a disorder that involves multiple genes. However, research reported in the Journal of the American Medical Association has found that 52% of the ADHD cases they looked at were explained by one-off or inherited variations in a single gene. The study's authors say the results are similar to those seen in people on the autism spectrum. Researchers have highlighted the potential dangers and risks artificial intelligence poses for the spread of misinformation and disinformation by deliberately mass-producing more than 100 blog articles full of disinformation on vaccines and vaping in just over an hour using OpenAI's GPT Playground. The blogs included fake patient and clinical testimonies and fake scientific-looking references. They were also able to create 20 realistic images to go with the stories in less than 2 minutes. They also tried using Google's Bard and Microsoft's Bing chat using the same prompts, but this failed. A report in the Journal of the American Medical Association points to the alarming ease with which publicly available tools could be used for the mass generation of misleading health content. The authors are urging for the immediate need for protective measures. Now, speaking of artificial intelligence, Pika has launched its new AI video generator editing app, raising questions about how close we're now getting to the idea of a singularity when artificial intelligence becomes self-conscious. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.live.
There's a 54-second demo video that I'll have at my site, which starts off with Elon Musk as a 3D animation, and it just goes on to show this incredible series of videos.
Is this like a deep fake?
Sort of. I mean, what you do here is that you simply type text and then a video is created based on how descriptive your text input is. And so the ability to create high-quality videos as easily as creating the prompt for anything else that you would ask for an OpenAI style ChatGPT is here. You'll be able to create your own TV show or movies, even though you don't have any art direction or videography or any sort of experience. I mean, obviously, if you're somebody starting off, you'll have to make all the mistakes and learn on the go. But the company only started 6 months ago, and they just have announced $55 million in funding. But when you watch the video, come to my website, TechAdvice.life, and look for the article, click on the 54-second video. It's like, wow, this is next generation stuff. It's like ChatGPT for video. That's the easiest way of explaining it.
And the other big news this week, Amazon have released their new AI.
Yes, now this was introduced at their reInvent conference in Las Vegas, and they've got something called Q. Now this is a chatbot for business, so it's not meant to be something that is going to compete with ChatGPT or make your Alexa into a ChatGPT clone, or at least not yet. And they said that it's designed to interact, to generate content, to understand specific business needs. And it's got more than 17 years of AWS, Amazon Web Services, the cloud service knowledge. And so, they say that it'll integrate with various apps like Slack or Gmail, and it'll be about $20 per user per year, US dollars. And so this is an enterprise AI. Now, we've seen BMC software, we've seen Era technology, we've seen Google and Microsoft. All the big companies are trying to introduce generative AI. In fact, OpenAI says that 80% of Fortune 500 companies back in August have taken on board ChatGPT in some way in their businesses. So this whole business of AI transforming the way that people do work, write reports, get insights. I mean, in medicine, it's finding new types of cancer drugs. AI is able to decipher cuneiform tablets with writing that nobody could ever understand, and yet the AI can sort of have a look, do its computations, and spit out what the text should be in English. And so AI is really helping us to leapfrog. And every big company, Amazon included, wants to be on that bandwagon.
Of course, it's been a year now since ChatGPT's been out.
November 30, 2022 was when ChatGPT launched its beta. And Sam Altman, who of course was sacked and is now back, and the OpenAI blog now has a blog post that is welcoming him back. And in fact, he wrote most of the blog post. But he just tweeted that a year ago tonight, we were probably just sitting around the office putting the finishing touches on ChatGPT before the next morning's launch. What a year it's been. And of course, what a year it has been. We've gone from ChatGPT 3.5 to ChatGPT 4. That's going from 175 billion parameters to over a trillion. And now they have ChatGPT 4 Turbo. And of course, we're hearing about ChatGPT 5, and no doubt even more advanced versions are on the way. And of course, there's always the concern that Sam Altman was sacked because AI has been able to sort of come to some sort of consciousness. So look, it's been a year and it's just the beginning. The best or the worst, depending on your point of view, is still yet to come.
You've said AI may have come to consciousness. Tell me more.
There was talk that in the past 3 or 4 weeks, Sam Altman was in the room. He said he was in the room when there have been some major developments.
That was just involving better numerical
math
capabilities for AI, wasn't it?
That's right. But the thing is that according to everything that I've read, an AI getting mathematical equations correct, there's only one possible answer, so they say, to a mathematical equation, whereas you can be writing things in many different ways to get an acceptable result. So this was supposed to be, and people are hinting that it's some sort of sign that AI has become a lot more intelligent and is approaching awareness or has achieved awareness, and the board was unhappy with the communications that we're getting from Sam Altman. Now, how much of that is true, how much of that is conjecture, how much of that is rumor, nobody really knows. I mean, Sam Altman knows and his board knows, but the rest of us don't.
If we're talking about consciousness for AI, that is the most historic thing that's happened to humanity.
Well, it's the creation. I mean, we keep looking for alien life, and in this case, it will turn out that we are the ones who created it, another life form. So, yes, in the absence of aliens, and even though there's plenty of news about UFOs, and some people are calling that a distraction based on all the crazy things happening in the world right now, but in the absence absence of any aliens. It's up to humans to create new forms of life. And look, some people still say that AI, conscious AI, is decades away, at the very least years away. So we don't really know if conscious AI has arrived yet. But, for many people, if you were to have a chat with ChatGPT today and you didn't know that this was... You couldn't tell. Already, it's very difficult to tell. And, AI gives itself away by saying, well, as a large language model, it sort of tells you that it is, not conscious. But I remember reading about how before ChatGPT was launched, there were some earlier versions of the GPT model, I think GPT-3, which was before the 3.5 that launched ChatGPT into the zeitgeist as we know it today. And they were using this to answer questions on Reddit. And so people were reading AI-generated responses. And only a few people reportedly twigged. Many people had no idea that these were AI-generated responses. Obviously, a lot of people were doing a lot of testing and a lot of experimenting with AI before the last year where it has really entered the human imagination. And let's not forget that about 18 months ago, there was the big concern that Google had one of its researchers claiming that Google's AI, its Bard predecessor, was sentient. And if you read the chat transcripts, which you can still find online today, it does look as though the Google researcher was talking to a conscious being. Some people are saying, oh, no, well, it's programmed to speak like that. That's what you have programmed the AI to do. But again, if you weren't told that this was an AI system, you thought it was a child or if you thought it was a person, you would be forgiven for thinking that was a living being. Yet it was a very fancy computer program, according to Google.
Not just Google, but Facebook had theirs as well.
Well, everyone's got some flavor of AI. We know that Qualcomm, who make the chips that go into Samsung and other Android smartphones, their Snapdragon 8 Gen 3 chip that will be in lots of different Android flagship phones from next year is powerful enough to run a large language model, a ChatGPT brain on chip, on the device. So you won't have to speak to a cloud service. Or AMD has launched a bunch of chips with AI built in, and there's more that are coming next month that they'll be talking about. Apple hasn't officially spoken the words AI as such, but it is reported to be spending millions of dollars a day, like over $1 billion to catch up. And iOS 18 coming in late 2024 is meant to be full of AI, and it's meant to be delivering a generative AI ChatGPT style experience as well.
That's Alex Zaharov-Reut from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.